So here is number 26. This is the one where they have given you the universal set is 1, 2, 3, 4, 5, 6. So that's why I drew a square. And I'll go ahead and put a U outside there just to indicate that the universal set is anything within the square. And then within that universal set, we know that there are three subsets, X, Y, and Z. So I went ahead and represented those with circles, and I've shown where they can overlap. And the thing you want to be aware of when you have three circles is you can have a place where just two of them overlap, and then you can have a place where all three overlap. And then, of course, the sections where it's just the elements in that particular subset. So as we look at the information we're given, the first thing they tell us is that X union Y, in other words, the elements that could be in X or in Y, are the numbers 1, 2, and 4. Now, I'm not going to fill any of those in yet because I don't know whether they're in X, they're in Y, or they're in both of them. I just know that they're in one or the other. So now I'm going to go to the next piece of information, which is that Y intersection Z equals 4. In other words, the only number that is in both Y and Z is 4, is the element 4. Well, that means 4 could show up in one of two places. 4 could be just where Y and Z overlap, which would be right there. Or if 4 also, it turns out, is in X, which it might be because we know that it's in X or Y, and it could be in both of them, then that would mean the 4 would belong in the very center because it would be in X, Y, and Z. And it would actually be the only element, it looks like, that would fit that bill, possibly. And so let's look and see. If we go a little further, I'm going to jump over the next piece of information and go to this right here. X intersection Y, yes, it is 4. So that tells me that 4 is in the intersection of X and Y. In other words, it's in X and Y. But it's also, from this earlier piece of information, in Y and Z. So I'm going to remove the 4 from the overlap of Y and Z and put it in the middle. So I've got 4 figured out. Now the next thing I'm going to do is, because that first piece of information, the X or Y, is a little bit ambiguous, I'm going to go to the primes, in other words, the complement sets, and see if I can get some information out of those. And it turns out that when they tell you what the complement of Z is, so if they tell you the complement of a set, like for instance Z, then they have also told you what Z is, because Z is going to be anything that isn't in its complement. So if 1, 2, 3, and 5 are not in Z, in other words, they're in the complement, then that means 4 and 6 are actually in Z. Well, if 4 and 6 are in Z, I already have 4 where it belongs. 6 is in Z, and I know that 6 is not in Y or X, because if it was, then it would have been included in their subsets in some way. In other words, the numbers that are in X or Y are 1, 2, and 4, and 6 is not listed there, so 6 can only be in Z. So I've got that worked out. Now I'm going to go to my other complement, which is the numbers that are in Y or Z's complement are 1, 3, and 5. So what that tells me is that the members of Y that are in Y or in Z, they're in one or the other, are 2, 4, and 6. Well, I already have 2 and 4 figured out. 2 and 4 are in, 4 is in all 3, and 6 is just in Z. That means 2 has to be in Y, so I'm going to put that there. Now that I know that 2 is in Y, and 4 is in all 3 of the subsets, I'm going to go back to this piece of information about the union of X and Y. In other words, 1, 2, and 4, those numbers are either in X, in Y, or in both of them. Well, they can't be, 1 could be in X, and I actually know that 1 is in X because 1 is not in Y. How do I know 1's not in Y? Because 1 is not in the union of Y and Z, because anything that's in Y or Z is in this set right here, and I don't see 1 there. That means 1 has to be in X. 2 is not in X. How do I know 2 is not in X? Because if it were in X, it's also, we know it's in Y. If it were also in X, it would have been included in the intersection of X and Y, and it's not there. So I've got 1, 2, 4, and 6 figured out. Now, what about 3 and 5? Well, 3 clearly is not in X, Y, or Z. I already know what's in Z for sure, and 3's not there. I know what's in X or Y. Again, I know what's in X or Y, and 3 isn't there. So that means 3 isn't in any of our subsets, so it can be in the universal set. So I'll just stick it outside in the square, but not in any of the circles. And then 5, we pretty much have the same issue. We know 5 is not in Z because Z is 4 and 6. We've already determined that. And 5 is not in X or Y because, again, if it was in X or Y, it would have been in the X union Y, and it's not. So 5 is also going to be on the outside in that universal set. And so now I've accounted for all of the elements in the universal set through a Venn diagram. Now what I can do is list the elements for X, for Y, and for Z. So if we take a look at X, the members that are in X are 1 and 4. Oh, whoops, I should probably do the set notation there. Let me fix that. So X is the set 1, 4. Y is the set 2, 4. And Z is the set 6, 4. And so that answers number 26. So if you still have questions on this one, I'd be happy to walk you through it again. Just come see me. But that's 26. We'll take a look at a couple of the other ones also.